A rocket carrying the James Webb Space Telescope was launched from Kourou in French Guiana, an unprecedented project that cost NASA $10 billion and was a decade and a half late for its scheduled launch. Named after the head of NASA in the 1960s, the gigantic spacecraft, often referred to as the Hubble successor, will help scientists look back billions of years, see the universe as a very young one, and see in detail how the very first stars and galaxies were born from the dust of the Big Bang. The priceless data collected bit by the golden mirror of the observatory will reveal to us the secrets of time and space, tell us about the evolution of galaxies, and perhaps even help humanity find a new home. The path of the telescope to the stars was, as it should be, thorny and stretched out for a quarter of a century. It was decided back in 1996 to launch the Next Generation Space Telescope, NGST, as the observatory was originally called. A year earlier, Swiss astronomers Michel Mayor and Didier Queloz had reliably confirmed the existence of the first planet known to us outside the solar system. It is this discovery, awarded the Nobel Prize in Physics in 2019, that can be considered the starting point of the mission. NASA realized that if exoplanets really exist, there was no certainty before, then a fundamentally new device is needed to search for and study them. Ground-based observatories are not capable of such a task. They see only rays that have managed to overcome the powerful filter of the Earth's atmosphere. Exoplanets, on the other hand, shine with dim, reflected light that does not reach the Earth's surface. This means that the new apparatus must conduct its observations from space. By that time, the famous Hubble had been operating in orbit for several years, but it was also not suitable for searching for distant planets. The optics of the telescope captures mainly only the rays of the visible spectrum, that is, those that are accessible to the human eye, and there, as experts explain, there is simply no chance to see distant planets. In the visible spectrum, exoplanets are not visible, since they are much smaller and fainter than their own stars, explains Oleg Ugalnikov, senior researcher at the Space Research Institute of the Russian Academy of Sciences. But in the infrared region, exoplanets can compete with stars. The planets are much colder, and therefore they shine primarily in the infrared range. NASA came to exactly the same conclusion: the Hubble should be replaced by an infrared space observatory. Having approved the mission project with an estimated cost of $500 million, the launch of the new telescope was optimistically scheduled for 2007. During the first year, the cost of work doubled to $1 billion. Over the next 4 years, another 2.5 times. In 2010, when $5 billion had already been spent on the telescope, that is, 10 times more than planned, and the launch of the long-suffering observatory was being postponed, at that time it was about 2015, the fate of James Webb hung in the balance. Each new delay increased the already astronomical costs, and this did not add sympathy to the project. They began to say that the long-term construction was too long, turning the telescope into a suitcase without a handle, one that is both inconvenient to carry and a pity to leave. Adding fuel to the fire was the fact that the global financial crisis that had erupted shortly before had not bypassed NASA. There was barely enough money even for the most important projects, so while the James Webb budget continued to grow by leaps and bounds, most other space programs had to be postponed until better times, and some even slaughtered in the bud. To understand the causes of the catastrophic overspending, the U.S. Senate conducted an independent investigation. As a result, an article was published in the journal Nature, entitled, "Neither More Nor Less, The Telescope That Ate Astronomy." It said that in order to save money, the authorities are considering all options, including the possible refusal to install on the telescope some instruments and other ways to reduce costs. Unable to wind down the overly ambitious project on their own, legislators came up with the idea of cutting NASA's annual budget by exactly the amount that was planned to be spent on James Webb. However, to the great surprise of the inhabitants of Capitol Hill, almost the entire world scientific community rose up to defend the telescope that devoured astronomy. The American Astronomical Society issued a scathing statement, calling the observatory the cornerstone of U.S. space astronomy for the next 2 decades and assuring that, whatever the short-term budgetary benefits of closing the JWST, the damage caused by this decision will be simply incomparable in scale. Scientists were supported by several influential international publications that trumpeted the story around the world, and as a result, the observatory was defended.